In this example, we're given a graph and we want to find the equation. So here's our graph that we want to find the equation of, and the first thing that we might see quite quickly is that this is a graph of tangent. So our base function will be tangent of x. And whenever you're doing a graph transformation, whether it's going from an equation to a graph or from a graph to an equation, it's a good idea to quickly graph out what tangent looks like. So if we do that, we remember that tangent starts on the x-axis, and then it has a point up above, then it has an asymptote, and it has a point below the x-axis, and then it repeats itself back onto the x-axis. That's our first special point. Our second point, the third point is the asymptote, the fourth point is below the x-axis, and that fifth point always is the same as our first point. And it would keep repeating in both directions. So our graph of tangent looks like that, which we can see is very similar to what the graph we're given is. Our graph has just been moved. So our process of finding the equation from a graph is really the same as going from an equation to a graph. First thing we're going to do is the period. Now, since our graph was tangent, what we should wind up with is y equals a times tangent of bx plus c plus d. Oops, let's go back to that process. We need to find b and c come from our horizontal transformations, which we'll do using the period and the phase shift. Our numbers a and d come from our vertical transformations down here at the last step. Again, just like with normal graph transformations, we do the horizontal transformations before we do any of the vertical transformations. Since our graph was tangent, we're going to use the formula pi over b to find b. And for the phase shift, we always use our formula negative c over b equals the phase shift. So once we use our period, we'll solve for b, and then we know b, so we can use our phase shift to solve for c. All right, let's go back to our graph. Our first special point of tangent was here on the x-axis, a point there. So we need to find where on our graph do we have a point in the middle, right? We have our graph on the x-axis. We no longer have any points on the x-axis if we notice. There's our x-axis, there's no points on the x-axis. So what do we notice? That point is a middle point. We have a point above the x-axis here, and we have a point below the x-axis. So what we want is a point in the middle. Any of these points in the middle would be acceptable as your first special point. Let's just pick one. Let's say this one. That'll be point number 1. All right, that'll be point number 1, which means we have point number 2 there. Point number 3 is an asymptote. Point number 4 is below the x-axis, and point number 5 is back the same as point number 1. All right, we need to see the distance between point number 1 and point number 5 is our period. All right, now it's a little hard to see our tick marks, but let's see if we erase my circle. We should be able to see those numbers again. Okay, so point number 1 was here, and point number 5 was there. So we start out with negative pi over 6, and we end up at pi over 3. So our period would be, we go from pi over 3 is our end point, negative pi over 6 is our beginning point. So our period would equal pi over 3 minus negative pi over 6. So minus and negative becomes addition. We need a common denominator, 2 pi over 6 plus pi over 6. And so our period is 3 pi over 6, which simplifies down to pi over 2. All right, now that we know our period is pi over 2, we also have our formula for the period. The period equals pi over b, since we were a tangent graph. So we combine these two together. We know that pi over 2 must equal pi over b, and when we solve for b, that gives us b equals 2. In this case, it's quite easy to see. We just have pi over 2 equals pi over b, so b must have been 2. However, if you have a more complicated one, just multiply both sides by b, and then divide by pi over 2, and you'll solve for b. All right, now we know what b is. B is pi over 2. We need to solve for c next. Okay. To solve for c, we use our phase shift. All right, our phase shift is where the x-coordinate of point number 1. So we look at point number 1. The x-coordinate was negative pi over 6. So our phase shift is negative pi over 6. But we also have a formula. Our formula for the phase shift is negative c over b. So we put negative pi over 6 equals negative c over b, and we know what b is. B was 2. So we get the equation negative pi over 6 equals negative c over 2, and we need to solve for c. To do that, we just multiply both sides by negative 2, and here they cancel, and that negative becomes a positive, so we get on this side the two negatives cancel, and we get c equals pi over 3, because that 2 and the 6 cancel. So we've now solved for c and b. So our equation, let's put that up here, y equals a times tangent of b was 2, 2x, plus c is pi over 3, plus a d outside. So again, how do we find that a and d? We look back at our process. A comes from any vertical stretching down here at the bottom. D comes from any vertical shifting. So we look, did we do any vertical stretching? In order to figure out if we have vertical stretching, we look for the distance between our special points. We look at the vertical distance. This vertical distance was at 1, 2, negative 1, negative 2, so our vertical distance between those points is 3 units. Our vertical distance between those points is also 3 units. And then we look at our base graph. Well, our base graph, the vertical distance, should have been 1 and 1. So, since we've changed a vertical distance of 1 into a vertical distance of 3, that will mean we vertically stretched by 3. So our A is going to just be a 3. All right, now we need to find what D is. We have 3 times tangent of 2x plus pi over 3, and we need to see if we did any vertical shifting. Well, our first point should have been on the x-axis, but instead it's down at negative 2. So what did we do? We shifted down 2 units. So that means we have D is minus 2 outside. So our final equation would be y equals 3 tangent of 2x plus pi over 3 minus 2. And that will be the answer to this question.